Ogos, hari cuti. Semua pun ada. Alhamdulillah. Nota dah ada ke? Nota ada tak dalam simpanan? Saya dah pas nota. Dah dapat tak nota?
Dapat.
Ada nota.
Ada Okey. Yang the same yang saya tengah tunjuk sekarang lah. So kita akan guna nota ni. Okay. Alright. So saya rasa kita mulakan terus Bismillahirrahmanirrahim. Okay. Alright. Hari ni tajuk kita adalah Hydrotest. Okey, tapi sebelum kita pergi kepada Hydrotest, saya akan go through sedikit tentang apa yang kita dah pernah cover sebelum ni. Konsep-konsep dalam pressure vessel ataupun ASME UG yang kita kena faham sedikit dahulu sebelum kita pergi ke Hydrotest lah. Okay, so kita kena faham beberapa konsep ni walaupun kita dah pernah go through, tapi kita go through sekali lagi. Tengok sama ada pemahaman kita dah 100% ke belum. Satu, pemahaman tentang allowable stress. Allowable stress ni kita kena betul-betul faham. Semuanya datang daripada kita punya stress strain diagram. Stress strain diagram ni adalah untuk material. Okay. Any material akan ada stress strain diagram mereka sendiri. Yang saya tunjuk ni, ini adalah typical stress strain diagram untuk carbon steel. Okay. Sekarang kita kena faham, apabila a certain material kita introduce stress, dia akan strain. Maksudnya dia akan elongate daripada kosong pada point A. Point A ni apa? Point A ni adalah dia punya yield strength. Ini penting. Pemahaman ni sangat penting. Sebab apa? Kalau stress ni, kita apply stress tidak sampai kepada point A, then we will know this material will go back to the original shape. Dia akan kembali balik kepada kosong. Therefore, strain pun akan kembali kepada original strain. Okay. Okay, semua dah masuk. Okay. Sangat penting Okay, dah masuk. Okay, tetapi kalau if this material, this carbon steel material, kalau kita apply stress sangat tinggi, lebih daripada A, lebih daripada yield, dia akan go to the region which we call plastic deformation. Plastic deformation. When it goes to the plastic deformation, kita kata dia dah permanently deformed. Permanently deformed. It means that if we remove the stress, no more stress, it will not go back to the original shape. Okay. Why this is important? Today punya understanding of hydrotest has something to do with applying the stress beyond yield strength for the point that is at discontinuity. We'll talk about that further, but understand this. 0 to A is the whatever stress below A is okay. When we remove the stress, it will go back. If it goes beyond point B, it will plastically deform. It will not go back to the original shape. Okay. So far, okay. Understanding ni. Okay, so we will build upon this. Okay, joint efficiency. This one we have covered in the last class. But we can say that joint efficiency can be considered as 1. E is equal 1 when we have full penetration or N 100% radiographic inspection. Okay. E equals 1. Okay, kenapa ada E? E is the joint efficiency. For any plate that we roll, if we roll then we put a long seam, we will weld. That weldment has efficiency lah. If we can say efficiency is 100%, if it's full penetration and 100% radiographic inspection. So if you can see this figure, ada 3 je, 1, 2, 3. This 1, 2, 3. You can consider E equals 1. other than this three type of weldment, we cannot consider as E equal 1. Okay, this one is both side groove weld joint. Alright, full penetration. This is considered full penetration. This also considered full penetration also, although this is one side, and we put a backing strip. But the backing strip must be temporary. If it's not temporary, we cannot consider E equals to 1. Okay, the other one is one side also, but we put a root with TIG welding. Only in these three case, we will have E equal 1. Other than this, E is not 1. Okay, understand this also. When we calculate shell thickness calculation using UG-27, later we'll see at the calculation, understand that R in the calculation, okay, alright. Understand that R in the calculation always refer to corroded condition. Corroded condition. It means that this is your shell. Okay. D is 2000, R is 1000. Okay. But corroded condition for R is not 1000. Look at this one. It needs to consider the corrosion allowance. Alright. Because up until here, it is considering corrosion allowance. So at corroded condition, you need to add the corrosion allowance 3 mm. Therefore, your R always 1003 mm after considering the corrosion allowance. This is at corroded condition. Okay, understanding the correction factor 0.6p. In our calculation, there is this 0.6p. What is this 0.6p? 0.6p is the correction factor. ASME has provided this correction factor 0.6p. Kenapa kita ada 0.6p? Because if we use normal equation, the equation that we studied in university, right? Which is the equation number 1. Equation number 3 is the thick. Equation number 1, the red one, is the thin one. You can see the deviation becomes sangat tinggi, sangat berbeza apabila thickness semakin besar. Between equation 1 and equation 2. Once we add this correction factor 0.6p, 0.6p by ASME, this deviation between equation 3 and 2, or between the thicker vessel, becomes very less. So that's why ASME add 0.6p. So when you open ASME UG code, you will always see this 0.6p. Understand that this is by experiment and this is a correction factor. That's why you have this 0.6p. Okay. All right. Now, moving on to our main topic today, we want to understand what is the reason of doing hydrotest. Okay, the reason of doing hydrotest, basically, okay, all is in. Okay. The typical reason of doing hydrotest is to check for leak. When we apply the pressure, we want to see there is no leak at the weldment or at the flange joint. This is typically what we want to see, no leaking. But the real reason we do hydrotest is we want to reduce the local stress. Okay. And this is mainly talk about at division 2, not mainly talk about at division 1. So division 2 is explaining the real reason why we do hydrotest, which is today what we want to understand. Okay, so you see this is the typical pressure vessel, horizontal with the saddle. Okay, you can see this is your shell, and your shell has thickness based on calculation. Okay, but you can see there is a nozzle here, and there is an opening here, and this opening, when there is an opening, you have what you call a discontinuity. Ini dah continue cantik. Without this, it will continue. But with the opening, you have discontinuity. Alright? And discontinuity, you have a higher stress. Okay? This stress is uniform. Stress along this line is uniform. But if we have a discontinuity, we have a higher stress here. You can imagine kalau kita makan, contohlah kita makan keropok lah. Keropok dalam plastik. Macam mana kita nak koyakkan keropok tu? Dekat bahagian atas tu kita akan nampak tajam macam tu. There is discontinuity. So bila kita apply stress dekat tempat tajam tu, kita boleh koyakkan keropok tu. So it's the same thing here. Because of keropok tu ada that tajam-tajam area kat atas tu, discontinuity. Bila kita apply stress, kita cuba koyakkan, dia boleh koyak. So imagine yang tajam tu tak ada, it's a lot harder to koyakkan the keropok lah. Okay, that discontinuity at the keropok allows you untuk koyakkan the keropok. So it's the same concept here. There's a discontinuity here, and there is a higher stress here, higher concentration of stress here. So the reason you want to do hydrotest is you want to reduce this local stress here at the discontinuity, at the nozzle or any other part of discontinuity. So far okay? So far boleh faham?
Okay,
Boleh.
faham.
Okay, Chun. Terima kasih. Alright, so tengok ni. This is the nozzle part Sini contoh nozzle part. Okay, you have the point A, you have the point B. Point A being here, away from the discontinuity. Point B is exactly at the discontinuity. This is at this. So point B is having a higher stress. Point A is having a uniform stress. B is higher stress. Okay. At discontinuity, we have a very high stress here. Okay. So imagine point A. Point A, when we apply hydrotest pressure, internal hydrotest pressure, it will go to the it will go to 1.3 1.3 of MAWP. Then when you remove the pressure, it will go back to 0. This is the formula. We'll go a bit detail on this formula later. Okay. Then we'll go. Okay. Now imagine at point B. This is understandable. During a hydrotest, the applied pressure is 1.3 times MAWP times LSR. I will explain what is MAWP and also what is LSR. This means the stress in the shell rise about 30% higher than allowable stress. Okay. Basically, 1.3 is above the allowable stress, and this is around 88% of the yield strength. Yield strength is here at point A. It will be around here. Okay, because it is not go beyond A, it's not at B. When we remove the stress, it will go back to the original shape. Okay, but different story at point B. Point B, to begin with, you already have a very high stress because this is discontinuity. So when you apply 1.3 times MAWP, you will go beyond A because originally you're not at 0 also. Originally you are somewhere here because of the higher stress. So when you apply hydrotest pressure, you will go beyond A, you will go to B, and this point B will be permanently deformed. 0, you will go to beyond A, then it will permanently deform. Okay. Then when you remove the stress, you remove the hydrotest pressure, it will not follow this path. It will follow a new path here. It will follow a new path, and at zero, zero strain, you will have a compressive point here. All right. So always point B will be having a residual compressive stress. Okay. All right. So we can ask if it's permanently deformed. Can we see that it is permanently deformed after the hydrotest? It is not permanently deformed after hydrotest because this point is very small. Point B is very small, and the other points, which is not having this higher stress to begin with, it's not as discontinuity, will push this point B to its original shape. So point B will go to the original shape, but it's having a compressive point here at minus. Okay. So later when we do a hydrotest a second time, it will follow this new. Okay, okay. It will follow this new line. It will not follow this line anymore. it will follow this new line. And when we apply 1.3 times MAWP, it will not permanently deform further because it has followed this new line. Okay. So far, is it okay? Understandable? This concept? Ada any question? If you have question, just you can ask. Can unmute and ask.
Boleh repeat balik tak yang pasal graph tu?
Okay, boleh. So start dari sini ke? This graph Okay, I will
Boleh.
repeat Okay. So imagine ada 2 point. Kita pergi atas. Kita ada 2 point sekarang. Point A is away from discontinuity. So point A is fine. Point B is at discontinuity. Okay, apa beza point A and point B? Point A ni, if we apply the pressure, alright, pressure will be uniform and pressure will be at allowable stress. Okay, so not so high. Pressure is somewhere here for point A. Point B is already at discontinuity. This discontinuity is to begin with, it is already have a higher stress at point B. Dia tak sama dengan point A. So point A is somewhere, point A starts with zero stress. When we apply, then the stress will naik lah. Tapi point B is already having a higher stress sebelum apply pressure pun, it's already at around here, atas sikit. Okay. So untuk point A, dia akan go kepada dia punya 1.3 times MAWP times LSR. Nanti saya akan terangkan ya. Tapi 1.3 times ni, it means that imagine this line yield strength is here. Okay. Kita punya allowable stress is 2/3 of yield strength. Okay. Kita buat satu line. Try to okay. We try imagine dulu. Yield strength is allowable stress is 2/3 of yield strength. So A is yield strength. 0 until A is yield strength. 2/3 is around here. Boleh bayang tak? 2/3 is around here of yield strength. Okay. For hydrotest, we apply 30% higher than allowable stress. So this line will go higher. It's about here. Okay. But not reaching A lagi. That's the main point. Not reaching yield strength. Okay. When we apply hydrotest 1.3, it is higher than allowable but not reaching A. By calculation, it's about 88% of yield strength. So masih di bawah yield strength kat sini. This is point A. Okay, when we remove the stress, it will go back to 0. Okay, that's okay for point A. But the whole reason for hydrotest is actually to entertain point B. We want to do something for point B. Because this point B, this discontinuity is having a higher stress. It is not starting from 0. That's the issue for point B. It is starting somewhere around here. And we cannot allow this higher stress to be in operation without doing something about it. Okay, this doing something about it is actually this hydrotest, the reason for doing hydrotest. Okay, so remember this hydrotest, why do we do hydrotest is to reduce local stress. Okay, local stress is point B. We want to reduce the stress because at the start it's already here. Okay, so how do we reduce this point B stress? So we apply hydrotest pressure. It will go higher than A. It will plastically deform. Okay, when we remove the stress, it will follow a different path. It is not 0A. It will follow a different path. It will follow Q to S1. Okay. This is the new path for point B. So later, when we apply, if there is stress inside the vessel, it will not start from higher stress because we have tamed. Basically, we have tamed the point B. We have tamed it by hydrotest. Now, it will start from S1. So when there is stress, it will start from S1 going up, then it will go down here. This is the new line for point B. So this is actually the reason for hydrotest. Beside having to check the leak. Okay. You need to remember hydrotest is actually, this is the answer for hydrotest. The answer is to reduce local stress. Where is local stress? Local stress is not here. Local stress is here at B. What is B? B is at discontinuity. Why do we have issue with B? B is having higher stress to begin with. Kita tak start apa-apa, but it's already a higher stress here because this is discontinuity. This word is very important, discontinuity. Discontinuity meaning higher stress. Okay, so how do we tame this higher stress? We do hydrotest. That's how we tame point B. When we do hydrotest, it will permanently deform. When we remove, it will go to a different line, not 0 to A, it will go from Q to S1, okay? And it is having a negative stress, which is compressing stress. So later when we have higher pressure inside the vessel, it will start from S1 and go up and go down. This is the new path for it. Not from here, because if it's from here, it will not start from 0, it will start from something here, because higher stress is already there. Okay? Boleh faham?
Faham.
Okay, Chun. This is the reason for hydrotest. Okay. Alright, try to understand. Okay. Okay. When the hydrotest pressure is applied, the stress at this point, this is point B, can exceed the yield stress, causing small amount of local plastic deformation. When the pressure is released, the surrounding elastic region, katakan yang ni semua point A, will pull back on this yielded zone, leaving behind a residual compressive stress. This is point B. Residual compressive stress. This effect is beneficial. It is a form of strain hardening. This is the word, strain hardening, that strengthen this weak point against future service condition. So point B now is strain hardening. We have strain hardened the point B. Okay. This is the whole reason for hydrotest, the main reason. Okay. Now we want to understand MAWP UG-99A. What is MAWP? MAWP is maximum allowable working pressure. The secret, basically the secret lah, to understand what is MAWP is actually at the W. W is working. Working. So working, there is 2 points that you need to consider. Working maksudnya in operation. In operation, you need to consider 2 things. One is corroded condition. That's why when we calculate, we always think of corroded condition. And also, we always think of static pressure. Then we will go further. Okay. So in simple word, MAW represent the vessel maximum safe pressure capacity at its weakest expected condition, meaning end of life thickness. Maksudnya, we do not take into consideration the corrosion allowance. Okay. Alright. Try to do this. If you have a pen and pencil, try to do this. We want to try again the UG-27 calculation. This is your data, 516 grade 70. Understand that 516 is actually carbon steel plate. Okay, 70 is actually 70,000 psi ultimate strength for this plate. Okay, you have internal pressure of 2 megapascal, temperature 100, inside diameter 2000. Okay, understand this. When you have a inside diameter 2000, your radius is 1000, right? But 1000 is not corroded radius. So later in the calculation, you need to take into consideration the corroded condition. Okay, S is allowable. S is allowable stress, which is 138 MPa. Okay, kita pergi sini saja. Item number 5. What is allowable stress? Go back to here. Okay, 0 to A. A is the point when you have a yield strength. Beyond this A, you have a plastic region. Okay, up until A is elastic. Go beyond A, go to B, this is plastic. So you cannot have a stress in normal condition. You don't want to apply stress at A. So you want to apply stress at below A. Okay. What is below A? Below A is 2/3 times this yield strength. 2/3 lah. 2/3. Ni 1/3, ni 2/3, ni 3/3. So 2/3 is somewhere here. Okay, this is your allowable stress. So point here is 138 MPa. Okay. Okay, that's why we put here as allowable. This one, allowable. Numbers. Okay, that's why we have a allowable 138 MPa. Why do we put here CA is 3 mm? For you to understand that in calculation, you need to put the corroded condition for the radius. Right? That's why you will see that this R is taken as 1003. Okay, corroded condition. Okay, E is the joint efficiency equals to 1. What does it mean by 1? That's why we try to explain this one. Okay, kenapa kita kata 1? So understand when we say 1 is either of these three condition Wellman joint only. Okay. So if we say E is 1, it's either one of these three only. Okay. Both side groove well, full penetration, or if one side with a temporary backing strip to be removed afterwards, or one side with a root using TIG welding. This is what you mean by E equals to 1. Other than that 3, E is not 1. E is something else. 0.85, something else. Okay, so now we calculate. You try to calculate this if you can. Try to follow along. This note is given to you, so you can print it and then you can put your own notes here. Okay, so T is PR over SE minus 0.6P. Where do we get this calculation? We get this calculation from UG-27. Earlier this month we have gone through this UG-27. So P is 2. 2 is 2 MPa. Our calculation is using megapascal and mm. This is your unit, megapascal and mm. So it's 2 times 1003 over 138 allowable times E is 1 minus 0.6 is the correction factor times 2. So you will get T equals 14.66 mm. This is your required thickness. Okay, your required thickness is 14.66 mm as per the internal pressure of 2 megapascal. Okay, but now we want to understand what is MAWP. Okay, this 40.66 mm thickness correspond to the internal pressure of 2 MPa. Okay. Okay, minimum design thickness is your required thickness plus the corrosion allowance. So your required thickness as per calculation is 14.66 mm. Now you want to add the corrosion allowance 3. Now if you add, you become 17.66 mm. Okay, once you have the minimum design thickness, you want to select the plate from the manufacturer. You want to select this 51670. Then you go to the manufacturer, and when you tell them you want a thickness of 17.66 mm, they cannot give you this 17.66 mm because this is calculated. What they have is higher than this, 18, 19, 20, something like that. So what they have is 18 mm. So we select the higher. So you select 18 mm. Okay. When you select this 18 mm, your corroded design thickness becomes 18 minus 3 corrosion allowance. Your corroded design thickness is 15 mm. So far boleh faham tak? Ada soalan tak?
Faham?
Faham Any question, just unmute tanya, saya tak sempat nak tengok chat just unmute and ask kalau tak faham. The reason you are here is you are trying to understand this. So if you have any question, just ask. If I can answer, then I will straight away answer. If not, I will take that. Then later I will tell you the answer. But please ask if you don't understand. Okay. your calculated thickness is T equals 14.66 mm. But now because you select a normal thickness higher, 18 mm, when you minus the corrosion allowance, you have a 15 mm. So if you recalculate 50 mm, this is your formula, P equals SET over R plus 0.60. If you calculate this P according to 15 mm, you'll get a 2.045 megapascal. It's higher lah because the design thickness 14.66 correspond to 2 MPa. But now you have 15. You have a 15, you have higher. 2.045 MPa. So it's higher than, okay. So your pressure taking capability is higher now because you are using 15 mm. Okay. So 2.045 MPa, is this your MAWP? This is not your MAWP. Okay. Remember, MAWP, the secret is at W. W is working pressure. So working pressure needs to consider two points. One is static head, the other one is corroded condition. So 2.045 MPa has not considered static head yet. Okay. Now you want to consider static head. So this one I put here. Static head is 0.01 MPa. So whatever you have, whatever you get, 2.045, you need to minus with 0.01. This is your MAWP now. Okay. If the static head is more, let's say your vertical pressure is more than 1 meter, it's like 3 meter, then this one, static head is higher, then you need to minus higher. Okay, so this is MAWP. Alright, so this is the important point. The word working is important. W, this W. It means that MAWP is not just theoretical, it's the maximum pressure the vessel can safely work in service. So consider static head, consider corroded condition. These two is important. Okay, so now you also might heard of MAP. What is maximum allowable pressure? There is W here, there is no W here. So this is not in working condition. It means that you will not take into account the static head and you will not take into account the corroded condition. It means when you calculate earlier, sorry, going up and down. When you calculate earlier, the selected thickness is 18 mm. So you will base on 18 mm. So use back the formula. This formula, P equal SET R plus 0.60. T becomes 18 mm. Okay. When you recalculate, you get 2.45 megapascal. So you get higher. Okay, but this is not working condition. Okay, so far okay.
Sir, can you repeat back the MAP?
Okay, alright. So MAP is maximum allowable pressure. The difference between MAWP and MAP is MAWP is having W. W is working. Working meaning that we need to consider two things, static head and corroded condition. So MAP without the working W is not considering these two. It is not considering static head. It is not considering corroded condition. Okay. So when you recalculate P using this formula, this T thickness, you want to take the nominal thickness, the one that you buy from the manufacturer. If you're buying 18 mm, so take 18 mm into this calculation and you'll get 2.45 MPa. This is your maximum allowable pressure. But this is not in real working condition. Okay. Is that okay? Understand?
All right. Thank you.
Okay. Okay, thank you. Okay. Okay, now we want to understand what is hydrotest requirement. Now we want to understand this. After all of that, now we want to understand hydrotest requirement. Okay, what is hydrotest requirement? UG-99, ASME 8, Division 1, UG-99. Okay, hydrostatic test shall be carried out on all pressure vessels. after fabrication has been completed and all examination has been performed. NDE, whatever it was, whatever it is, already completed. Now we want to go for hydrotest. Okay. What is the exception? The exception is if we want to go to pneumatic test. Pneumatic test is using air, hydrotest is using water. But all of the time, if it's permitted, we always want to go for hydrostatic test. Okay, because hydrostatic test is safer. Hydrostatic test, if you have a leak, what will happen is water will come out. So you know there is a leak. But for pneumatic, if there is a leak, it will go like a explosion. Okay. So always prefer hydrotest, always. Tapi if this vessel cannot comprehend water, cannot tolerate water, the vessel must be very kering, dry condition always, and it's not feasible to dry the vessel, then we can opt for pneumatic test using UG-100. Okay. Alright. So now this one I put here, Hydrotest much safer. Okay. UG-100. This is the condition. If we want to use UG-100, but 99% of the time we use Hydrotest. Okay. So now we understand that this is your formula for Hydrotest. Minimum. This word minimum is very important. 1.3 times MAWP. I've already explained MAWP. So what is this? LSR. LSR is lower stress ratio. Why is this lower stress ratio coming into this formula? It's because of one thing only. Because when you do the hydro test, you are doing at your workshop or at the ambient temperature. Okay, you are doing at the workshop at whatever the ambient temperature was, maybe 30 degrees Celsius, something like that. But if you put the same pressure vessel under working condition, this temperature will be much higher. Maybe it's 200, maybe it's 300 degrees Celsius. So a concern can be if you are doing the hydro test pressure, is it really representing what is happening at the actual condition at site with the higher temperature? So that is the concern. So to solve that concern, we have a LSR, lowest stress ratio. So what is this? It's only dividing between the allowable stress at hydro test at ambient, okay, and allowable stress at operating condition. Okay. Maybe I will show ASME 2D. I will show after this. What do I mean? Okay, I will show now. Hold on. You hold on for 1 minute. I will open ASME 2. ASME. Okay. Can you see this ASME 2D ke? Boleh nampak ke?
Nampak.
Nampak Bukan note Okay, nampak ni. Okay, this one Alright. Okay. Okay. We want to understand LSR. Okay, you see this is your ASME 2D mechanical property. You see this is table 1A. If it's table 1A, then you can use this for division 1 punya calculation. If it's 2A, then that is the division 2. So if it's division 1, always look at table 1A. A means ferrous material, B means non-ferrous. So we want to see our material just now is 516, 70. So if you look at 516, You can see this is carbon steel plate 516, but this is grade 55. Ours is grade 70. So you need to look further. 516. Okay, this is 60. 65. Okay, this one. SA 516, grade 70. What is this? This is a carbon steel plate. Okay, this is item number 45. Okay, so you look at the third page. 45. SA. Okay, at 45. You can see at 45, this is the temperature. At 40 degrees Celsius, the allowable is 138. Same as what we did just now, 138 here. Okay. If the pressure vessel is operating at 300, this allowable stress becomes 136. Okay. So you can see as the temperature rise, the allowables becomes less. Okay, this means that any material subjected to higher temperature, the strength of the material become less. So allowable stress also become less. So LSR means at this 138, at this ambient temperature, you want to divide by whatever the operating temperature it was. If the operating temperature is 300, you will take 138 divide by 136. So you get the LSR ratio. Now it is representing. That's okay, Farmer? So this 1.3, you times MAWP, you times 138 over 136. You get the rate ratio. Now hydrotest pressure, when you use UG, this is UG-99B. When you use UG-99B, hydrotest pressure, this figure is actually minimum. Minimum. 1.3 times MAWP times LSR is the minimum. So based on UG-99B, you cannot have a hydrotest pressure which is lower than this, because this is minimum. Okay, the word minimum is important. Okay. Note here, if MAWP is not calculated, you can substitute this MAWP with design pressure. Okay. And if this is minimum, what is the maximum? Okay. So from code, there is no upper limit for hydrotest pressure. But that doesn't mean that you can go way beyond to so much stress. Okay. Because if there is a visible deformation on your vessel, your vessel can be rejected. And that's the worst case scenario. So although code is not saying what is the maximum you can go, but code is suggesting the maximum you can go is UG-99C. Okay. Okay, what is UG-99C? We have covered MAP. UG-99C is 1.3, you times with MAP, and then you need to minus the static head. That's your upper limit. So a hydrotest for your vessel can go minimum UG-99B or maximum UG-99C. Okay. Is there any question? Okay, boleh faham ke? We have come to the end. Okay. So any question, please ask.
Saya ada soalan.
Uh-uh.
Regarding the HT kan?
Okay.
You know?
Okay, we dengar.
HT ni biasa will be performed after everything completed, right?
Yes.
But sometimes I face client want the hydrotest to be 2 times. Let's say for equal fabrication, they want to have the HT for the header box before the tube inserted into the header box. and the second time is after the completed. So I am thinking that if let's say they want the HT to be done for the head box only, mungkin diorang maksudnya sebelum header box tu will be welded and no painting. So they want to have HT. Is it because diorang fikir let's say kalau after painting, the painting will cover the leak. So
Yes.
does
So,
the painting can cover the HT? I mean the HT pressure.
no, because if there is leak, it needs to be visible lah. You nak tengok dekat weldment tu, if there is any crack after HT. So if you have already painted, then it's difficult to see lah. So you want to do the hydrotest first, then later you can paint lah.
Tapi macam HT kan ada pressure dia. What is the minimum pressure? Then takkanlah macam painting thickness tu boleh cover the pressure for the HT. Dia tak akan macam nampak leak juga ke?
Maybe it's not a visible leak. Maybe some crack only. Mungkin dia belum betul-betul leak, tapi crack, ada crack, ada mini, ada some small crack ke. Jadi if you paint, this small crack tak nampak. So that's why you want to complete first, then you want to check the weldment. All the weldments is okay, then you can proceed with the painting lah.
Alright. So HT kita observe not only by air nampak keluar but also at crack lah, at weldment.
At weldment, yes. The understanding is there is no crack at the weldment. We do not want to see this. But your welding quality cannot be very bad though, because if E is equals to 1, you have already put the one that I showed before, that weldment, you already 100% radiography, you already full penetration. If your E is not 1, then your welding thickness is already high. So usually you will not see any crack after hydrotest lah, because of the RT yang you dah buat semua lah. But it is a requirement from the client to see if ada lah. But the true reason for hydrotest is you want to reduce this local stress. That's the main reason.
Do you think it is necessary to have 2 times?
2 times. 2 times maksudnya hydrotest tu buat 2 kali
Betul.
Okay, so tadi macam ni, first one dia buat sekali tu bila?
Untuk header box only, and second time is after completed.
Okay, after completed. This one I will check. Fatima? Okay, I will check this one, then I will come back to you. I'm not sure, sekarang ni I'm not sure kenapa 2 time. I will check. Okay,
thanks.
Thank you. Okay, is there any more question?
Question, sir.
Okay.
For example, after doing a HT, do we need to replace all the gasket from to new one?
Okay, gasket replacement meaning do we open back that flange?
If we require to change new gasket, then we open lah. Tapi based on PTG, I think it stated that after doing HT, we need to change a new gasket lah. Is it really a requirement lah for based on the codes?
Okay, this one I will check also. Siapa nama?
Afiq.
Afiq nanti WhatsApp saya. Nanti saya confirm dengan Afiq. But it makes sense because this pressure when you are applying this internal pressure, you're applying 1.3 times. 1.3 times the allowable stress. So it's very much higher than your operating pressure or design pressure lah. So maybe because of that, your gasket is being more compressed kan macam tu. But I will confirm with you Afiq. WhatsApp me
Alright,
Okay,
thank you. Okay, thank you, sir.
Okay. Any more questions?
Question
Sir, nak tanya soalan?
Okay. Boleh? Salah soalan?
Okay. Saya pergi dulu.
Okay.
Nak tanya yang tadi, yang compressive stress tu.
Okay.
Maknanya yang point B tu, is it going to be in negative?
Betul.
Boleh explain boleh tak?
Boleh. Okay, sekejap ya. This point B. Okay. Let's go back. This point B. Okay, this is at discontinuity. Discontinuity, when it starts, it is already having a higher stress. We already have a higher stress at point B. Okay, so it will not start at 0, it will start somewhere above 0 because of the higher stress at discontinuity. Okay, when we apply 1.3 times MAWP, it will go beyond A. When it go beyond A, it will have a plastic deformation. Okay, this plastic deformation, we understand it, katakan macam getah dia macam dah tertarik kan. So when it goes back, when we remove the stress up until here, we understand this plastic deformation will maintain lah. Maksudnya kat point B tu akan jadi besar sikit daripada yang lain. Tapi point B ni is very small points. And then the other points above point B tu is not having a higher stress to begin with. Dia orang macam point A. Jadi point A ni yang banyak-banyak ni dia akan tolak balik. Point A yang banyak-banyak ni dia akan tolak balik point B to its shape, original shape. Okay, this original shape sebabkan dia kena tolak balik dengan ni strain kan. Dia sepatutnya dekat sini, di strain. Tapi bila dia tolak balik, semua tolak balik sampai ke strain 0, dia tak pergi ke macam ni. Dia akan turun ke bawah ke sini. So this point, this is stress, this is positive, this is 0, this is negative. So this will be under negative compressing for point B. Okay. Boleh faham ke?
Okay.
So correct.
So
Dia
when we apply another steam, we start from S1 tu lah.
Betul. Dia akan follow S1. Dia akan follow ke S1 ke Q. Q being another plastic deformation, but it will not reach Q. It will go to the allowable. If it's allowable here, it will go to allowable, then it will go back. Okay.
Alright, thank you.
Okay, thank you. Tadi ada lagi soalan lagi siapa?
Hello.
Hello, ya.
Sir, let's say kita hold HT and then pressure drop tapi bukan sebab leak. Berapa tolerance yang kita boleh set?
Okay, HT pressure drop. But no leaking lah.
Yes.
Pressure drop without leak. So this could be a temperature factor lah. Mungkin dia tengah buat tengah hari kan. So panas. So ada pressure drop sikit. Okay, berapa tolerance This one I need to check. Boleh lebih tu nama ke?
Iqbal.
Okay, Iqbal boleh WhatsApp saya?
Okay.
Okay, then I will check I cannot answer right now, tak sure. Nanti I will check. Okay, ada lagi question?
Sir, satu lagi.
Okay.
What is the recommended holding time untuk HT?
Typically 60 minutes for this.
Okay. Is it stated in the codes and standard?
Code and standard. Let me get back to you on that. Okay, holding time siapa
Adib.
Adib Okay, holding time. Okay. I will get to you Adib. I think after this, what I will do after this class, what I will do is we will have a session on typical hydrotest punya procedure lah. Typical hydrotest procedure. Okay, then
And
I think
one more thing, sir.
yeah.
Actually, during HT, kan, most of the procedure, it will go from 0 to 30%, and it will hold like about 10 minutes. Is there any reasons behind it?
Okay. Kenapa we hold for 10 minutes after 30%? Okay, I think this reason, if we hold, then we can check if there is any leak at the weldment, at the joint. Because if you go beyond 30%, go to straight to the hydrotest pressure, this is a very high pressure already. So if there is any leak, you will see straight away the leak is gushing forth lah. So before that, you go to 30%, hold it first, then you can inspect dulu, tengok dulu. Kalau tak ada, so all is good, all is okay, then you can add that pressure lah. Add more pressure to the required hydrotest pressure. Okay. So this one I will cover in our next class. I will do a class on a typical hydrotest procedure. Then I think it can answer your question. We will go one by one on the procedure. Okay. Ada question lagi? This is very good feedback. Very good feedback for me. The one that I have penned down, I will answer. Afiq, Iqbal, Adib, I will answer to you. And then based on this feedback, the next class should be joint efficiency, right? But based on this feedback, we will do one class on the typical hydrotest procedure. I think that will help. Is that okay?
Maybe next class can discuss on the question yang tak resolve tadi.
Boleh. I'll put that one also in the next class. Okay, thank you. Okay, any other one? Okay, so kalau tak ada, kalau ada just WhatsApp if it's required. Kalau ada, saya rasa tak ada juga. Okay, so just to show this is our module. Okay, later we will go joint efficiency, but before joint efficiency, we'll do a class on the hydrotest procedure. Then we go to selection of material for pressure vessel, PWHT, and also NACE 0175 and 0103. We'll go through this, and also inshallah I will sambung belajar sikit. Okay, and this master degree is by research, and my research will be what is the gap between industry and also academic. This is my research, and then I will, if it's okay, I will need your participation also lah, if I have a question, because this will answer the question, what is that gap between the industry and also the academic. So I want to find this gap, and then based from the gap, I want to see how can we basically close the gap lah. Okay. Alright, all. Thank you for your time. If there is no more question, we will adjourn today. We'll see you in the next class. Next month, 2 classes. The first class will go for the hydrotest pressure and answering all the 4 question. Alright. Then we'll start the next class next month. Okay. Any more question? Okay, guys. Thank you for your time. Thank you for coming. I'll see you in the next class. Okay. Assalamualaikum. And thank you all.
Salam. Thank you.
Terima kasih.
Salam.
Okay, terima kasih.